All right, good evening. So welcome back to College Algebra. And today we are going to talk about polynomials. Okay. So fortunately, this gets to build on stuff that you already know how to do. There's a lot of that. So with polynomials, okay, let's see. The first thing we're going to want to do is talk about the end behavior of a polynomial. Okay. So let me just spell out what a polynomial is. It's going to look like we're going to have some kind of a constant. So we'll say A0. Okay, that the subscript is just which one it is. Plus A1 x to the 1, right? So it's a line. And it could stop at any point, right? We could stop right here. And that would be a polynomial, and that would be just fine. A2x squared. And that would be a quadratic, so we just did those. So it's a subtype. We can add another one. A sense. It should probably see a pattern. Okay, so dot, 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 up to whatever we're going to go up to. Okay, so I wrote this in what they call ascending form. Normally we write them in descending form because we usually write this thing at the highest and then they go down. But there's nothing that says we can't write from the smallest one and crawl all the way up. All right. This n, right, that's the degree of the polynomial. Right, so if we had like, 3 plus 4x plus x squared, that would be just fine. That's a degree 2. Okay. So n is the degree. The a sub n is the leading coefficient. All right. Because most of the behavior we're going to talk about really only deals with that term there. Okay, it's not that the other parts aren't important, and it's not important. It's not that they don't do anything to the function, but the biggest things that you're going to see are going to involve these two pieces here. All right. So we kind of break this down. We say, well, if n is an even number, right? So here we're talking about x squareds, x to the 4th, x to the 6th, x to the 8th, etc. Okay. Then we're going to have the behavior is going to look like this. If my a sub n is a positive number, right? Like that polynomial or that quadratic I just gave you, it opens up, right? We say it opens up. So I know my end behavior of my polynomial is going to look something like this. This is the end behavior. If my leading coefficient is negative, okay, we're going to be looking at something like that. Okay, so some examples might be 3x squared plus 10x plus 3, 5x to the 10th minus 17. Okay, all of these would be, this is positive, this is even, moving up. Okay, so like this, 4 minus x squared. Okay, 16 minus x squared minus 4x to the 4th. Okay, so minus x to the 6 plus 17. Okay, so all of these are, even. Okay, but the leading coefficient, because it's the thing in front of the highest degree polynomial. So even though this is what's positive, like no, the leading coefficient is the one that's attached to the highest x. The leading coefficient is the one that's attached to the highest x. The leading coefficient is the one that's attached to the highest x. These are all negative, so my end behavior is going to look something like this. Now, the rest of these little terms in here are going to be responsible for what wiggles it's going to have here, but the overall behavior, right, the end behavior is going to be dictated by these first terms here. Okay. And I think they just have us go through and do that a couple of times. All right. Next thing we get to worry about is the zeros of a polynomial. And usually we mean rational zeros, but we'll get to that. Often if they want you to solve for the zeros, it will either be something you could factor, or they're going to give it to you in factored form, right? So if I give you the zeros like this, and I say f of x is equal, and we have an x minus 3, x minus 5, and x plus 7. Okay. If I were to multiply all of these out, right? I don't suggest doing it, but this is positive, this is positive, this is positive. They're all going to be a positive. The leading term is going to be positive, and it's just going to be like a 1x to the 3. So I know that my, oh, we're not done yet. I only covered half of it. We said if that is an even number, it's like, what about odd? Okay, like in this case, what about odd? Okay, I know we have more to say about that. If n is odd, okay, and again, it breaks down. It breaks down between what's the leading coefficient say. Okay, so if my a sub n is a bigger number than 0, right, it's positive, then we're going to end up with a graph that's going to look like this. All right, so x cubed plus 3x squared plus 3x plus 1. Leading coefficient is positive, right? And is odd, we're going to end up with this. If I were to multiply this all out, right, we'd have an x to the 3, it'd be positive. Okay, we have the same kind of behavior. All right. Leading coefficient, right, is positive, and it's odd. So this one, right, when x is 0, y is 2. So even though it's like a much abbreviated sort of a polynomial, it's still got this end behavior of the first quadrant's moving up, the third quadrant's moving down. Okay. If a sub n is negative, okay, we're still talking about odd degree polynomials here. Okay, if the leading degree is odd, then this is going to flip. All right. So something like 3 minus x. Okay, it's an odd degree. The leading coefficient is negative. This one, right? When x is 0, y is 1, 2, 3. 3. Oops, and that goes through the 3 there. Okay, but this mirrors what's going on here. 1 minus x to the 3. 1 minus x to the 3. Those are different. All of these are going to have a leading coefficient that's negative, and the polynomial is going to have odd degree. Okay. So why don't we do a couple of those and see how we fare. More notation. I usually don't like to use this notation until you guys actually hit calculus, because that's what this is really used in. But what they're saying here is as x approaches negative infinity, okay, what this means is as my debt, because we're going to negative infinity and that's debt, as my debt grows without bound, so I just stop paying my credit cards and just let them go, that's what this is going to happen. X is going to go to negative infinity, right? You're going to be in debt up to your ears, where even your great-grandchildren will not pay that off. Okay. Then f of x, right, is going to, they're asking you what this is going to. So, or say as x grows to positive infinity. Okay, I'd usually like to say this like x grows without bound, or x tends towards infinity. I try to be a little bit more poetic about it than just x approaches infinity, because that's kind of weird. Then we're going to ask, what's the behavior of the function here? Okay, so there we go with that. Okay, so let's do a couple of those. Okay, so we'll say as x get, well, let me give you a function first. Okay, so we'll say f of x is equal to 3 minus x squared. Okay, so as x goes to negative infinity, right? As x tends towards negative infinity, f of x, right? We're going to take the negative infinity here and put it in and square it, right? So pick a big number, okay? I don't know what the national debt is right now. That's a nice big negative number, okay? But pick whatever favorite negative number you have that's really big, put it in there. 3 minus that is going to be even more negative. So f of x tends towards negative infinity. As x tends to positive infinity, well, this function, it didn't really matter, right? If I put in positive, put in your biggest number, your favorite biggest number. My favorite biggest number is 6.023 times 10 to the 23rd power. Taking chemistry, you will know that number. But if I put it in here, right, 3 minus this number squared, also goes to negative infinity. Okay. So let's try another one. Let's go with how about f of x is equal to 1 over x? Okay, it doesn't have to be a polynomial for us to use this notation. So we're going to say as x tends toward positive infinity, what's the graph of 1 over x look like? They go further and further and further along, right? 1 over that number is going to be very, very tiny. F of x goes to 0 as x tends towards negative infinity. So again, we can look at the graph. So as x goes further and further and further out, f of x still tends towards 0. Okay. In calculus, you'll do the other way around. You'll say, well, as x tends towards 0, okay, and they'll say 0 from the right, so I'm looking at it 0 this way. Then f of x, that one goes without bound. And as x tends toward from 0 to the left, right, then f of x tends towards negative infinity. Let's see. Let's go with f of x equals the square root of x. Okay, so we'll say as x tends towards infinity here, then f of x, right? You guys know what the square root function looks like that. F of x tends towards infinity. As x tends towards 0, I can't really say as x tends toward negative infinity. That wouldn't make sense with this function. Okay, so the best I could do is get close to 0 from the right. F of x tends towards 0. Okay, there's a lot of this in calculus. Okay, this is most of what you do, at least at the beginning of it. All right. So that's that notation. It's a little bit weird. I'm glad I spent the time going over that, because you'll revisit this in a later time. You'll see it again. All right. So as I'm looking at this, right, we'll say, here's my function. Okay. We have an even degree, right? The degree is even, and the leading coefficient is negative. So whatever else I know about this function, I know that the end behavior of this function looks something like that. Okay, this is negative 3x to the 4th minus 5x squared minus 2x plus 3. Okay, I'm glad I don't have to do anything else with this except stare at it and say that's pretty. But since my a of n is negative and n is even, I know that's what it's going to look like. So as x tends toward negative infinity over here, right? As further over as we want to go here, f of x goes to also negative infinity. As x goes to positive infinity over here, well, f of x doesn't change. It's still pointing down. All right, we have that. Let's continue on and see what the next one is. Okay, more in behavior. Very good. So this one is a little bit different. We have 16x to the 5th plus 7x to the 4th minus 6x cubed plus 8x. So they don't have to, it doesn't have to be in order. Or I shouldn't say in order. They're allowed to skip. That's okay. So then we have 3. We didn't have a 2, 1. That's fine. Okay, so what's going on here? I know my leading coefficient is positive. Okay, and n is a positive, n is an odd number. So a sub n is greater than 0, and n is odd. So what that's going to look, it's going to look just like x cubed. All the odd polynomials look like x cubed, unless they're flipped, unless they're reflected. Just like all the even ones look like parabolas, give or take. All right, so I know that there's my end behavior. So as x tends towards negative infinity, f of x also. I don't want to put an equals. Don't put an equal sign there. Okay, because we don't equal infinity. We tend toward infinity. Right. And as x tends toward infinity another way, as x grows without bound, f of x also grows without bound. All right. Some books deal with positive and negative infinity just to make sure that you have the point. You don't have to put positive infinity, and I think this book probably yell at you if you do. But if handwriting, it's not the worst thing in the world to write that. All right. So this one, they want us to think about what's going on with this function, and it looks like they kind of want you to multiply it out. They do not. Do not multiply these things out unless you absolutely have to for your own peace of mind. We're just going to count them. So here's my m of x, and we're saying this is negative 3, x minus 3, 3x plus 2 squared, x plus 6 to the 4th. All right. So what do we have? If I were to multiply this out, there'd be an x to the 4th plus some stuff, right? If I multiplied this out. In this one, there would be a 9x squared, just squaring the first term because it's squared, plus some stuff. And in this one is x minus 3, so just x minus some stuff. And then minus 3 at the beginning. Notice all of these are positive. Times 1 negative. So my leading coefficient, right, is going to be a negative 27. You don't need to go into it that heavy. Okay, you don't need to be that detailed. All you have to do is note, like, hey, it's negative. But since I had what was going to happen here, I'll just say it's negative 27 since we know. But you don't need that. All you need is the negative part. Okay. Now, if I were to multiply all these together, right, we'd have an x to the 4th. We'd have an x to the squared here. So if I multiply these together, I get an x to the 6th times 1. We get an x to the 7th. Oops, let's not do it that way. That's what I want. And then plus a lot more stuff. We only care about this part of it. We really do. We only care about that part. All I'm saying with this is, x to the 7th, right? We have 4, 5, 6, 7. That's an odd number. And my leading coefficient is less than 0. So if I ask you, like, hey, what's negative x cubed look like? I'd say negative x cubed looks something like this. Right? And that's what the behavior is for this function. As horrible as this looks, this is what we have. All right. So x goes to negative infinity, x tends towards negative infinity. My f of x is going to positive infinity. Okay. As x tends toward positive infinity, then f of x tends towards negative infinity. Okay, again, try not to write the equal signs, I know. So positive infinity, this one is going to negative infinity. All right. But they really do not want you to multiply all of that out. Okay, you got better things to do. Okay. This one is sneaky. All right. So again, let's just write this down. We have 6x to the squared, right? 3 minus x, 4x minus 5 cubed. Now, if it helps you to write this down in the descending order, so we have negative x plus 3, that's okay. I'd rather you have a coping skill or a way of ironing this out than to try to just, well, let me just flip a coin and, we'll see what happens. Like, no, I want you to get it right. So here we've got a negative x times a negative 6. It's going to be positive. Okay, you see how they snuck that in there on us? They're trying to fool us here. All right. So we know negative times negative is going to be positive. And then if I were to multiply this out, right, this would be this thing cubed. Not multiplying it out. I have a negative x plus some stuff here. In this case, stuff is 3. And I have a 6x squared. So this x cubed times this x, that's going to be an x to the 4th. X to the 4th times x squared is going to give me a 6x cubed. Right, well, times 64. All right. So there we have all of this stuff. Okay, so what do we say? This was 3, 4, oops. That's not an x cubed. 3, 4, 5, 6. Okay. So we have so our 64 times 6, that's positive. Our 6 is an even number. So even though it's trying to trick us, we know that this looks like a parabola with positive coefficient. So it's going to look something like this. Again, there'll be some wiggles, but this is the basic shape we're looking at. Right, so P of x is tending toward infinity. As x tends toward positive infinity, well, then we are still tending toward positive infinity. So that's our deal there. Okay. Next thing we're going to do is we're going to find zeros. Now, what we're looking for is where does it cross the value. So if I have something like this, right, we're looking for where does it cross. Okay. Now, in this case, they kind of told us, right? We could use the zero factor principle and get the values here. Sometimes they're going to spell it out for you and they're going to do this. That's great. Other times they're going to say, well, you guys remember how to factor, right? I hope you do. Well, you're going to get a quick refresher course here. Okay. So almost all the time, you can group these as sort of a 1-2 and a 3-4 sort of a rhythm. So almost always you're going to be able to group them like this, right? The first pair and the second pair. Occasionally, okay, some books like it when the 1 and 3 and the 2 and 4 make a natural pairing. Okay, that's not as common, but it's more common than the other kinds that we're going to talk about. Okay, very rarely, a pair is 1 and 3, or 3 and 1. Sorry, my cat is, we can't do to her because she has a heart problem, and having babies would also be problematic for her. So we just get to tolerate her once in a while. I was going to show her to you, but tonight she's very cute. But try to remember that when she's driving us nuts. Okay, so that's where we are. All right. So for this one, the factory, they're not trying to be too tricky about this. They're just doing 1, 2, and then 3, 4. Okay, so if I want to factor this, we've got x cubed plus 4x squared minus 9x. Is it minus 36? I'll bet it is. It is. So what we're going to do is we're going to pull an x squared out of the first two terms. We have x plus 4. And I'm going to pull out a 9 out of the next two terms. And if I pull out a negative 9, it swaps the sign. Pull out a negative 9, it swaps the sign. Then notice we have an x plus 4s here. So that's going to sweep out in front. And then left, we have that. And you say, oh, I could factor x squared plus 9. And here we have a factor polynomial. Okay, not going to lie to you. Your book picks specific problems that you can do this with. All right, it's very easy to come up with a problem that you can't do and you can't factor it at all. And at that point, I get to say to you, welcome to the wonderful world of numerical analysis, where we get to do zeros by searching with a computer. It's a different class. But most of your problems are going to be able to do this. All right. Okay, so then we're going to use zero factor principle. Right? We're just going to pull all these apart, right? If a times b times c is equal to 0, then a equals 0, b equals 0, or c equals 0. One of those things has to be true, or all three of them could be true, but you know, but that's what's going to. One of those has to be 0 for this thing to be 0. Okay, it doesn't work with any other number. Okay, if I ask you, I said I got two numbers, right, and they're equal to 1. Best of luck to find that number, right? So one of them's 1. Like, no, that would mean both of them are. If a was 12, then b would be 1/12. Okay, if a was pi over 6, then b would be 6 over pi. There is no end to how many numbers you can pick. Okay, so we have this. So either x plus 4 is equal to 0, x minus 3 is equal to 0, or x plus 3 is equal to 0. Okay, meaning that x is equal to negative 4, x is equal to 3, x is equal to negative 3. So if you're ever doing something by hand for me, if you go from here, this step, to this last step, I'm gonna know what happened. All right, I'm not gonna take off points from going from here to here. I will tell you that I really like to see like this zero factor principle step, because in the future, they're not gonna be this easy. You're gonna have to have this, and you're gonna have to do a little mini problem in here. Okay, but for now, if you jump from this step to that step, there's no explanation. I'll know what happened. Okay, and there's our zeros. Okay, that's what we have for zeros. So we're going to say the zeros of G, and they're not telling us to put them in right ordered pairs. They're just saying list them. Okay, so we have negative 4, negative 3, and 3. That's it. That's all they want. Okay. I'm used to putting them in order. Just it looks nicer. But if you don't, the book isn't going to care. I'm not going to care. Okay, so if you want to be a math teacher someday, practice putting them in order. But if that's not in your future, it doesn't matter. Okay. Now, when we go to graph this thing, sometimes you're going to notice that you get a parabola that just touches the bottom here and goes back up, right? We'll call that A. And I know that we just moved that as a horizontal shift, right? So if I had x squared and then we compared it to x minus a squared, that just means we have, right, we're just over here. We just moved the vertex. That's it. Well, in polynomial speak, right, when we're dealing with a slightly broader idea of what could happen, notice this is the 2, and it kind of bounced off of the axis here. That's what they mean by the multiplicity. Okay, so if you've got a factor, right, like we just did, x minus a, and we've got some kind of an n up here, n is even, then f of x will bounce. Okay, if n is odd, then f of x breaks through the axis. Okay, so when I factored this, right, we just factored it, right? We said, oh, one more up. These are all ones. So all the multiplicities here, they're all 1. Okay, nothing to see here. It's all 1. It's boring. We're just going to go with that. So -4 has a multiplicity of 1, 1, and 1. They all have multiplicity of 1. All right. Oops. We will get the graphing them, by the way. I assure you we will do some of that. All right. Oh boy, this one's going to be fun. Okay. So here, okay, we have g of x is equal to 15x cubed minus 24x squared plus 9x. Now, what I'm looking at for this one is that, well, at least there's an x common to everybody, but there's also a 3. So if we pull 3x out, what am I going to have left here? Well, I'm going to have 5x squared. And I check this as I'm doing it. So what I'm doing here is I'm saying, well, 3x times 5x squared, does that give me 15x cubed? Yeah, okay, I'm okay here. Minus 8x. If I multiply this back, do I get, you know, am I going back to here when I multiply this through? 3 times 8, 24, yep. Minus sign, yep. X times x, x squared, good. And then just plus 3. 3 times 3, 9, okay. Or 3 times 3, we have an x here, good. So now we have to factor this. Okay. Now, some of you, I'm sure, because I know that they teach this in a slightly different way than I see it in math, what is it, 970, 980. So some of you have seen this. If you haven't, this technique is called the AC method, factoring. I will demonstrate it, and I'll show you. If you want a more focused demonstration, I will recommend the YouTube channel Math by Fives, and then AC. Just type that into your YouTube, Math by Fives, AC method. Okay. So what we're going to do here is we're going to identify the first and the last one. So if we have quadratic formula, right, that's ax squared plus bx plus c. That's why it's called the AC method. Okay. So 5 times 3, that's 15. And then what we're going to do is we're going to see if we can't find factors of 15 that happen to add up to 8. Okay. Well, we have 1 and 15. We have 3 and 5. Oh, I think we found it. Okay. So they're both going to be negative, right? Because negative 3 times negative 5 will be positive 15, and these will turn into that. Okay, so what we're going to do, okay, is we're going to break this 8 into a 5 and a 3. Now, there's no rule that says you have to do it this way. I just tend to like to group like with like because it makes my factoring a little bit easier. So I'll group a 5 with a 5, and then I'll group a 3 with a 3. Notice that 5x minus 3x minus 5x minus 3x is still minus 8x. I'm just saying that I'm going to pay you with my left hand $5, and I'm going to pay you with my right hand $3. Okay, but I'm still paying $8. So we have 3x, and then we have, notice there's a 5 common in both of these. So that's a 5. There's an x common in both of these. So we're going to have x minus 1 here. And then I'm going to pull out a negative 3. And that's going to change that sign and change this sign. All right. So there we go. All right. X minus 1. 5x minus 3. All right. All right. I know that's not going to last. All right. So there we are. We factored it. All right. Now, if I want to find the zeros, we're going to have 3x equals 0, x minus 1 equals 0, or 5x minus 3 equals 0. See, like I said, sometimes you got to put a little work into them. And again, if you can go straight from here to here, I'm not going to ask questions, okay? That's fine. We'll know that you can go from here to here. And then this one always confuses people for some reason. I never know why. Okay, but those are my zeros. And again, all the exponents here, all ones. So those are my zeros. So the zeros of G are 0. Okay, actually, let me check what these are here. We have, 0, 3/5, and 1. And 1. And they each had multiplicity of 1. 1, 1, 1. What are we up to? We're up to 6. Tell you what, let's call it a night for tonight. Say that we're doing really well, and we'll pick it up next week with more polynomials, and we'll just keep going. Hopefully she'll be out of heat by then. All right, so I'm going to go ahead and close this out and say stop recording to the people that are watching, and